Good afternoon and welcome to my discussion on optimal IoT work placement in a fog environment. My name is Kenneth Moore. I'm a data scientist for Dell EMC. I'm also a research student, a PhD student at Cork Institute of Technology. And this work that I'm presenting today is a project bringing industry and academia together with the support of the Irish Research Council. So I started this research by asking a simple question of what are the current trends at the moment in workload placement? What are other people in this area looking at and how are they achieving it? So that leads me to what are the considerations required for placing IoT workloads in the cloud? To begin that, we need to understand what does a fog environment look like, and courtesy of the Open Fog Consortium we get this image, right? And in your typical cloud environment, you have your devices at the edge and you talk to the cloud. But in a fog environment, we have this layer of abstraction in the middle where we have multiple servers right from the cloud right down to the devices. Here's an example, again, courtesy of the Open Fog Consortium, of where we would implement such a system. In this system, you can see the levels of abstraction. At all the terminals, at the arrivals, at the parking, at security, we have near edge fogs nodes. We also have second level fog edge nodes, which pass information between the different sections of the airport. And then if we need to pass data outside the airport to other areas, we have the cloud environment. So in trying to answer this question of what other people are looking at in this area, I've obviously gone through quite a lot of literature, and in that literature I've come across quite a number of topics. This is a summary of the key areas where people are looking in this area of IoT workload placement, and the focus of my research is on task workload placement. So the first question I asked myself when I started looking at this topic was, what are the options for workload placement? What are those locations in the fog environment? Again, looking at the fog system here, the first approach that people would take is this broker auction approach. This is where the edge device sends out a request for processing. All the near edge devices in that locality will be analysed, and the most appropriate near edge fog node will be selected to process that task and feed response back to the appropriate device. The second approach taken in industry is a distributed approach. Again, all the near edge nodes are analysed and examined, check to see which could be the best approach, method to place, and in this particular scenario it's decided that the best approach to take is to distribute the workload across multiple devices, and then again, once completed, send it back to the device. The last approach is taken is this hierarchical approach, where again we analyse all the near edge nodes. We look to see which of them might take the workload task, and we decide actually none of them are appropriate for this particular use case, and the workload is sent to the next level up or to the cloud, and response returned back. So who makes that decision? Through research I found one example, or two or three examples, where the IoT device itself makes that decision. So the IoT device looks at what the near edge servers are, looks at what its needs are, and makes that decision. In one particular case, I even found where the data packet sent out by the IoT device included the application in a Docker container. Another approach is where the workload task is sent to the cloud service. So the cloud service then looks at what needs to be done, has a look at what near edge fog nodes are nearby to the device, and then sends that workload back to those. But in reality, the best approach taken is the software-defined infrastructure controller. I call it software-defined infrastructure controller. Other papers are looking at software-defined networking. Others call it software-defined data center. Ultimately, it's your control plane. Your control plane sits in the community of the fog edge nodes. It gathers a cluster together, and it has visibility of what's going on in those fog edge nodes, so it can make an appropriate decision. This is by far the most common approach taken, and actually, the person who was presenting here just before me presented Pulse IoT, which is an example of the SDI controller. So we spoke about where to place, we spoke about who makes that decision. But how do they make that decision? What are the factors required to make that decision? Again, there's 3 key areas that look at here. The most common, most obvious is resource awareness, right? How busy is the nearest fog edge node? How busy is the CPU, the RAM, the storage? Does it have the capability of actually taking the load that's coming towards it? Another approach taken is to look at quality of service, quality of experience, and I suppose I should probably add in here as well quality of information, right? Where again, the controller is not looking at the resource utilization, but it's more focused on, can we deliver the service that the device is requiring? Can we deliver it within a reasonable amount of time, and can we deliver it while the information is still valid? The last approach that is taken is energy awareness. Now in energy awareness, there's 2 aspects here. There's carbon footprint and there's battery power. Looking at battery power first, you might have a mobile edge node that's sitting on a cell tower that's powered by solar power. And in the evening when the sun is gone, it's working off battery power. So we want to make sure that the fog edge node that's going to run the workload can actually sustain the workload for its entirety without the battery running out. The second aspect is carbon footprint. In this world of environmental awareness, yes, carbon footprint is becoming important, and a lot of people are looking at this area of how do we minimize energy consumption in our environment. So if we take both of these into consideration, when a workload task is processed out and sent out to the controller for consideration, the controller will look at or make an estimation as to how much power will be consumed by that workload task. It will then, in the case of the battery power, it will look and see is there enough battery power remaining in that device to run the full workload. No point in running the workload if the battery's going to run out, right? Or alternatively, it will look at all the nearing fog edge nodes and say, okay, if I take the entire cluster as a set, how can I minimize my carbon footprint in that environment? Of course, the reality is you don't take one of those, you take all 3, right? So software-defined controller will look at various algorithms, and this is where the research of the papers are looking at, is the algorithms that are used to make these decisions. And, you know, it might take all 3 with equal weighting. It might weigh one over another, or, you know, whichever it decides is best. For example, it might look at the battery power first and say, okay, we'll identify all those nodes that are not going to be at risk of running out of battery, but then we'll look at the quality of service. If we still have a number of servers left that are possible location places after quality of service has been identified, we then move on and see how can we minimize the resource utilization amongst those servers. Now, in making that decision, if it's a small environment, we'll say 5, 10, 15 nodes, well, we can do a deterministic approach here. We can look at the first node, the second node, the third node, calculate the impact on all those nodes, and then come up with a decision. But in reality, you know, even in an environment like VMworld here, you might have thousands of nodes spread across the entire facility, and looking at it deterministic is not a realistic approach here. So in that case, you're going to take a heuristic approach. You might do a genetic algorithm, you might do a travel salesman algorithm, you might take some sort of machine learning AI algorithm that will scan through the possible locations and figure out what is the best approach to take. So where does that leave me? No, I've now identified where we place them and why. I've identified who does that job. I've identified the algorithms and the methods that are used to do that. But, you know, how can I take this further, right? Where are the optimization opportunities here? And I leave it with one question, right? One thing I didn't consider here is, what environment do you need to run your workload? We have loads of cloud environments out there. You know, does your application, has it been designed to run in a VMware vSphere environment? Has it been designed to run in a Kubernetes environment? Well, look, luckily there, you know, Kubernetes runs on vSphere, but it might be Azure, it might be Docker, it might be something else. In 5 years' time, how many more different cloud providers are going to be out there? In 20 years' time, how many more are going to be out there? And let's face it, in 20 or 30 years' time, we'll have millions and billions of devices, but we will have devices that are set up today that we still want running in that period of time. So our environment that we set up has to be able to deal with all the different setups. And still, once we've figured that out, go back then to those optimization methods and employ those. Thank you. Any questions? Thank you very much.